All right, we're halfway through the first trimester and we're finally getting into bonding. So we're going to do a little bit of review and then add some more depth to your knowledge of ions with these first couple of lessons. So first thing we're going to talk about is monatomic ions. So just think about the parts to that word. We've got mono. You may recognize that as meaning one. And then we also have atomic, which what does that sound like to you? Atom. All right, so monatomic ions, all right, are going to have something to do with one atom. So let's see what that means. So quick review, atoms sometimes gain or lose their valence electrons, all right, those are those important outer ones, to form bonds, and we call these atoms with missing or extra electrons ions. All right, so when an atom gains electrons, all right, we're talking we've got extra negative charges. All right, are we overall positive or negative? All right, so if we have more negatives, extra electrons, that's going to make an overall negative ion, and we call that an anion. And then when an atom loses electrons, right, so we give away some of that negative charge, that makes a positive ion called a cation. So make sure if you have forgotten these words, you get those back into your brains and what charge the ion has in those situations. But look over this diagram and see if you can answer some of the questions. All right, so the first one says, identify 3 elements that form only one cation. All right, so cation, we're looking for something that forms a positive ion and it only forms one of them. All right, so I will give you a hint. Strontium is an example. Aluminum is an example. So is lithium. Can you list some more? All right. So everything here, here, and then a couple in the middle form only one possible cation. All right, and then identify 3 elements that form only one anion. All right, so anion, that means we're looking for a negative charge. So what are some elements that form anions and they only form one? Hopefully you've started listing anything over in this section. Those are all single anion elements. Or yeah. All right, so now identify 3 elements that form more than one cation. Process of elimination. All right, everything else that's left, you can see they kind of have these options. There's more than one way they can form their cation. All right, there's also, where do most of those fall on the periodic table? All right, so this is your transition metals tend to form multiple possible ions. Whereas generally, if you're not dealing with a transition metal, they only form a single ion. Of course, you can see a few exceptions to these rules, but that's the general trend you can work with. All right, so putting this all together, sorry, I have an extra letter in here. How many atoms are in a monatomic ion? That's where the mono comes from. There's only one. All right. All right, so what kind of ions do metals tend to form? If you need to rewind, look at that last slide again. But If you remember, metals are the things on the left side of the periodic table, nonmetals are the things on the right side of the periodic table. Everything on the left was forming positive cations. So what kind of ions do nonmetals tend to form? Again, if you need to, look back. But those form anions. So something that you want to learn, all right, is that there were two different ways to name the groups on our periodic table. So we had 1, 2, let's see, and this was 18, 17, 16, 15, 14, 13. All right, but if you looked really carefully, these also had another way of naming them. 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. All right, so those A numbers tell you how many valence electrons. All right, and if you remember, we talked about this briefly, but there's that octet rule, and this is the whole reason why our noble gases don't react, is that our atoms find themselves the most stable when they have 8 valence electrons. All right, so noble gases are already there. They don't form ions, right? Because they don't need to give up electrons or gain extra ones or anything like that to get to 8. The rest of these group A ions have a very stable pattern in how they form their ions. All right, your metals, all right, so everybody to the left give away, they form cations, and they give away the number of electrons they have in their group number. This is just a way to remember it, which makes sense because group 1A has 1 valence electron. It's going to give that 1 electron away. That's going to be easier than stealing 7 electrons to fill the shell, right? So group 1A forms +1 ions. Group 2A has 2 valence electrons, so it's going to give away those 2 to form a +2 ion. And group 3A, similarly, will give away 3 electrons instead of trying to steal 5 to fill up the shell. And then that's where that kind of rule falls apart. Group 4A has kind of the ability to do either or. And honestly, these guys tend to be more involved in covalent bonding, which we'll talk about after ionic bonding. And then when you get to group 5A and on, these guys, it's easier for them to just take on extra electrons. So for your nonmetals, if you take their group number, their group A number, and you subtract 8, that'll give you the ion charge. Essentially, you're figuring out how far away it is from 8. Right, so 5A, 5 minus 8, will give you a -3. All right, it's going to pick up 3 electrons, because it currently has 5, to get to a full octet. Group 6A, 6 minus 8 is -2. It's 2 electrons away from 8. And group 7A is going to pick up 1, or have a -1 charge. All right, so this is so that you understand the reasoning behind this stuff. This is so that you can take a nice little screenshot and have this handy so that you, in the future, if you have to tell me what type of ion will calcium form, you just need to sit there and go see, oh, calcium is here on the periodic table. And since it's in group 2A, it'll form a +2 ion. So go ahead, use your new knowledge and tell me what kind of ion chlorine and barium will make. So chlorine is in group 7A, so that means it'll make a -1 charge. Barium is in group 2A, which means it'll form a +2 charge. So last thing, just because I know you're going to see a question related to this, we're going to do a lot more practice with this in a future lesson. But the general way an ionic bond forms is that ions combine so that they are electrically neutral. All right, so there's no overall charge. We have to cancel the positive and the negative. All right, so you always have to combine a positive ion and a negative ion when you form an ionic bond. All right, so for example, if you have aluminum, which falls in group 3A, so it's going to form a 3+ ion, and you want to make an ionic bond, should you combine it with magnesium, that forms a 2+ ion, or fluorine, which forms a 1- ion? All right, if we want to be electrically neutral, we have to have a positive and a negative, so you're going to combine aluminum and fluorine. Now, the next caveat to this is how you combine them. All right, because right now, if we were to do 1 aluminum and 1 fluorine, our overall charge, all right, if I do +3 plus -1, that's +2. I need my overall charge to equal 0. All right, so I have too much positive charge. I can't make aluminum form a different ion, but what I can do is I can bring in some more fluorines so that I get it so that there's 1 aluminum with 3+, and then 3 fluorines with -1 each to form aluminum F3, AlF3. All right, we will definitely practice with this a lot more. I just know you have a question about this one on your quiz.